Some people, like the Andaman Islanders, that's a community living in the Gulf of Bengal, see them as burning torches thrown into the air by forest spirits. Others, like some Australian Aborigines, think they're flaming sticks ridden by shamans. If you ask an astronomer though, they'll tell you that a comet is a large object made of dust and ice that orbits the sun. Arguably, one of the most famous space objects of this kind is Halley's Comet. It has left a great impact on our history and understanding of these mysterious falling stars. When this comet passed Earth in August of 1835, for example, it was blamed for the New York City fire that kept going for several nights. At the same time, the Seminole Indians in Florida saw the comet's long tail and believed it marked the day they would lose their independence. This comet came back in 1910, and people yet again saw it as a sign of bad luck. In Chicago, people bent over backward to secure their windows to protect themselves from the comet's dangerous tail. Others bought all sorts of gadgets, like umbrellas or masks protecting from comets. But what's so intriguing about this space body? How come it just pops up around Earth every once in a while? And most importantly, is it really dangerous? Halley's is what astronomers call a periodic comet. It visits us every 75 years or so. On rare occasions, some lucky people get to see it twice in their lifetime. It last passed Earth in 1986, and it is expected to come back in 2061. Despite this scheduled return, the comet's orbit can't be predicted with precision. That's partly because of the chemical processes happening inside the comet. Halley's orbit may also change due to random interactions with other planets and space objects in our solar system. Its official title is 1P Halley, and it's named after English astronomer Edmund Halley. He was the one who studied the reports of a comet nearing Earth in 1531, 1607, and 1682. Based on his calculations, he concluded that these three occurrences had been, in fact, the same comet, returning over and over again. He also predicted its return in 1758. Halley's discovery also pointed out that some comets, like this one, orbited the sun, but their journey was not circular. If you look at it in 2D, Halley's orbit looks like an elliptical wire dangling from the sun. Sadly, Halley didn't live to see the comet's correctly predicted return, but it was named after him. According to the European Space Agency, the first sighting of Halley's Comet dates back to March 30th, 239 BCE. Asian astronomers noted it down in the Shiqi and Wenshengtao chronicles. But another study claims that we might have first noticed it even earlier than that, during the times of the ancient Greeks. Writings from that period reported a huge meteor that landed in northern Greece, leaving the local population perplexed. It soon became one of the ancient world's most popular tourist attractions. But the authors also noticed a comet in the sky at the time the meteor landed. They also reported the fact that the unusual space object had remained in the sky for about 75 days. Shakespeare himself seems to have written about this comet in his play Julius Caesar around the year 1600. In this work, he included a now famous phrase speaking of comets as unusual signs, saying, "The heavens themselves blaze forth." It wasn't the last time famous writers felt a certain connection with this object. Writer Mark Twain even said in 1909, "I came in with Halley's Comet in 1835. It is coming again next year, and I expect to go out with it." Surprisingly, Twain passed away on April 21st, 1910, one day after Halley's had emerged from behind the far side of the sun. We got a better look at the comet when it last passed us in 1986. Several spacecraft were sent toward Halley's to take samples of the comet's composition. This fleet of spaceships, dubbed the Halley Armada, flew nearby, one of them taking several pictures of the comet's core for the first time in history. We also had much better telescopes to look at the comet as it swung by our planet this time. Based on current studies, there's little to no chance that Halley's Comet could actually pose any danger to our planet. Most of the bad things associated with the comet were just fabrications. Even better, comets in general may have made life on Earth possible. Specialists believe that early in our planet's history, collisions with comets brought a significant amount of water here, which helped to form our oceans. These space objects may have also gifted us organic material necessary for the formation of life. Don't confuse comets with asteroids though. Unlike asteroids, which are small rocky space bodies also orbiting the sun, comets are mostly made up of frozen ammonia, methane, or water. They contain only small amounts of rocky material. Because of their composition, comets are sometimes nicknamed dirty snowballs. Comets are made of 4 parts: a nucleus, a coma, a dust tail, and an ion tail, but their nucleus makes up most of their total mass. There are over 3,000 comets that we know of, but astronomers think there may be up to 1 billion of them in our solar system. A comet that is bright enough to be visible from Earth without the help of a telescope is called a great comet. Approximately 1 great comet can be seen every 10 years or so. People have noticed other comets for millennia. However, scientists have concluded that since comets shed a lot of material each time they orbit close to the sun, their lifespan may be only thousands of years. If you compare that to the age of the solar system, which is 4.6 billion years, it's a relatively small number. Since these space bodies are still present in the solar system today, there must be a source of comets somewhere out there. Otherwise, all comets would have disappeared a long time ago. Another famous comet is named Hale-Bopp. It came very close to Earth in January 1997. The last time it was seen near our planet before, that was during the Bronze Age, back in 2000 BCE. This comet is much larger and more spectacular than Halley's. Its nucleus stretches for up to 24 miles in diameter and can be seen from the surface of our planet with the unaided eye. Comet Borrelly was the second comet to be studied up close by a spacecraft. NASA's Deep Space One approached it in 2001 and gave scientists a detailed report of the comet's black core. This comet is surprisingly lopsided, but the reason for its unusual shape is still up for debate. Halley's comet appears to have formed in the Oort cloud at the outer edges of the solar system, but Borrelly is said to come from an icy cloud of rocks beyond Neptune, which is called the Kuiper Belt. Comet Hyakutake gave us quite the show when it passed just 9.3 million miles from Earth in March 1996. It looked like an ice blue splash with a faint gas tail. This comet amazed astronomers too, as it produced X-rays 100 times more intense than scientists had predicted. A spaceship called Ulysses passed through Hyakutake's tail in May 1996, reporting that it was at least 350 million miles long. That's double the size of any other known comet's tail. The comet Wild 2 was examined by NASA's Stardust spacecraft back in 2004. The probe managed to fly within 147 miles of the nucleus of Wild 2, giving us some of the best comet pictures to date. It was also the first time we got samples of dust particles from a comet. The precious cargo came back to Earth in January 2006. Its aim was to shed light on the conditions under which Wild 2, and the solar system for that matter, formed those billions of years ago. Wild 2 is about 3 miles in diameter and covered with craters and cliffs. It's the year 2031, and the first human has just set foot on the red surface of Mars. It was a long flight that lasted 172 days. It was a tough journey. There were lots of technical issues. There were some physiological obstacles. Astronauts had to deliver tons of equipment and energy-generating and life-supporting systems to the red planet. Those responsible for the mission had to understand how to deal with low-pressure atmosphere and catastrophic sandstorms, how to keep people safe on Mars' surface, and how to bring them back to Earth after their work is done. It does sound like a science fiction story, but soon it's going to be our reality. But the coolest thing? It's not the limit. After exploring Mars, people might set even more ambitious goals, and this is what some of them may look like. The next planet to visit could be Venus, but it would be a challenging task. Venus is also called the morning or evening star, all because it shines so brightly in Earth's sky that it's the first one to appear after sunset and the last one to vanish after sunrise. But in terms of exploration, Venus is very unfriendly to humans. Its atmospheric pressure is about 92 times as great as the pressure on Earth. And the temperatures on its surface are, on average, 850 ZWF. Modern technologies wouldn't allow us to build an infrastructure that would allow people to survive on the planet for longer than a couple of minutes. But then, why would we set sail for Venus? Here's a curious thing. At the height of 30 to 40 miles above the surface of the planet, there are the most Earth-like conditions in the entire solar system. The pressure there is almost the same as in the mountains on Earth, and the temperatures range from 70 to 85 AF. If the planet's atmosphere was made up of oxygen and not toxic gases, we could live there without any additional equipment. Or we could go to Phobos and Deimos. Those are Mars's moons. It would be the first time humans set foot on the moon of some other planet. Phobos is located a mere 3,700 miles away from the surface of the red planet. It would take no longer than a day to reach it. This potato-shaped piece of rock is quite small, a mere 13 miles across. This is the reason why it has very weak gravity. Deimos is a bit farther away from Mars, about 15,000 miles. But this mini-moon is even smaller than Phobos. It's a bit more than 7 miles across. In other words, visiting these moons wouldn't be unlike landing on an asteroid. And the greatest challenge astronauts would face would be leaving the surface of Mars. To do it, they would need loads of fuel. So, most likely, the first trips to Phobos and Deimos would be launched from space stations orbiting Mars. We could set an even more ambitious goal and head for Jupiter and its moons. The distance between this gas giant and our home planet is 365 to 600 million miles. This distance can be so different because the planets follow their elliptical orbits around the Sun, getting closer then farther apart. The minimal distance occurs every 13 months. If people set off on this long journey during this period of time, it would still take them about 2 years to get there. Since Jupiter is mostly gas, on-planet exploration wouldn't be possible. We could probably fly around the largest planet in the solar system and even dive into its atmosphere. But much more interesting for exploration objects would be Jupiter's moons. Let's say Europa. This natural satellite has a water ice crust. It can be from 10 to 15 miles thick. Under this crust, there might be liquid water. The core of the moon might consist of liquid metal inside a rocky shell. Its super thin atmosphere contains some oxygen. Considering all this, it would be a rather comfortable place for people to explore, if not for its temperature. It doesn't rise above 240 HF. We could visit another Jupiter's moon that is called Ganymede. It's an ice satellite with a very thin atmosphere that contains oxygen, or Callisto. It's the second largest among Jupiter's moons. Its icy crust is about 124 miles thick, and it's very cold on the moon, around 200 to 1 F. People could also send an expedition to Saturn and its moons, for example, Titan or Rhea. The gas giant itself is twice as far away from Earth as Jupiter. It means it would take astronauts more than 3 years to get to this planet. But if the spaceship was launched from a space station on Mars, it could reduce the travel time by 25 to 50%. But even if the starting point of this expedition was Earth, with advanced technologies like nuclear thermal propulsion, such a journey could take just a year or even less. Saturn can't be explored directly, so researchers would probably start with its largest moon, Titan. It's also the second largest moon in the solar system. This natural satellite has an atmosphere that mostly consists of nitrogen. The pressure on its surface is twice higher than that on Earth. There are winds and rain on Titan, lakes and rivers, but those consist of liquid ethane and methane rather than water. It's actually a good thing. We'd have a lot of resources to produce fuel and energy. Rhea is the second largest of Saturn's moons. It's made up mostly of water ice. Its atmosphere is super thin, but it also has some oxygen in it. Actually, all the largest moons of Saturn have only one serious drawback: it's freezing cold there. On the bright side, they all have plenty of resources to produce energy and other life-sustaining elements. And it would be much easier and faster than the same process on Mars. But what if we could explore exoplanets? Those are planets that travel outside our solar system. If we manage to get so far away from Earth, maybe we would reach some potentially habitable worlds. It could be Proxima Centauri b. It's the closest to Earth exoplanet, and recently, astronomers have found out that this world might resemble Earth even more than they previously thought. It's only 17% more massive than our home planet. It orbits a star that is dimmer and less massive than the Sun. Proxima Centauri b is in the middle of the star's habitable zone. This means that the chances are liquid water and life might exist on the planet. It looks like the exoplanet is tidally locked with its parent star. It means one of its sides faces the star at all times, and the other is always in the darkness. Scientists haven't figured out yet whether the planet has an atmosphere. It's traveling too close to its star, so the radiation from the star might be pulling the planet's air away. If this is the case, Proxima Centauri b isn't likely to have liquid water on its surface. It would take way longer to reach potentially habitable Gliese 832c. This exoplanet is 16 light-years away from Earth. In the cosmic scheme of things, it's a stone's throw away. Gliese 832c is 5 times as massive as Earth, and travels much closer to its parent star. That's why a year on this planet lasts a mere 36 days. But since this parent star is a red dwarf, it's much cooler and dimmer than the Sun. So, Gliese 832c gets as much light and heat as our planet does. At the same time, it's still unclear if Gliese 832c is similar to Earth. It probably has a much thicker atmosphere that creates a runaway greenhouse effect. This phenomenon occurs when a planet absorbs more heat from its host star than it can release back into space. This means that, unfortunately, Gliese 832c is more likely to resemble scorching hot Venus rather than relatively cool Earth.
Bang, or should I say Big Bang, the Big Bang, So, after the Big Bang, the universe resembled a hot soup of protons, neutrons, and electrons. After it started to cool down, the protons and neutrons began to combine, first forming ionized atoms of hydrogen and, later, some helium. These ionized atoms of helium and hydrogen attracted electrons, turning them into neutral atoms. As a result, the light was able to travel freely for the first time ever, since it was no longer scattering off free electrons. What does it mean? The universe was no longer dark. At the same time, it was still about a few 100 million years after the Big Bang before the very first sources of light started to appear. That's when the cosmic dark ages came to an end. We don't know for sure what this universe's first light looked like or how the first stars formed. Luckily, we have the James Webb Space Telescope to help us find the answers. How come? All because this is an infrared telescope. Why is it important? Let's figure it out. Imagine a star. It's a very, very old star. Maybe the first star out there. Light leaves this star 13.6 billion years ago and settles off on an incredible journey through space and time. It needs to get to our telescopes. By the time this light reaches us, its color, our wavelength, shifts toward red. That's something we call a redshift. It happens because when we talk about very distant objects, Einstein's theory of general relativity comes into play. According to it, the expansion of the universe also means that the space between objects stretches, making them move away from one another. But that's not all. Light stretches too, which shifts it to longer wavelengths. Eventually, this light reaches us as infrared. In other words, redshift means that light that is originally emitted by the first stars or galaxies as ultraviolet or visible light gets shifted to redder wavelengths by the time we catch a glimpse of it here and now. For the farthest objects with very high redshift, that bare minimum of visible light is shifted into the near and mid-infrared part of the electromagnetic spectrum. That's why to see those space objects, we need a super powerful telescope. And if we talk about the Webb telescope, it can see back to about 100 million to 250 million years after the Big Bang, which is incredibly awesome. So, by observing the universe at infrared wavelength, James Webb lets us see things no other telescope has ever shown before. The primary goal of this incredible piece of equipment is to study the formation of galaxies and stars that formed in the early universe. To look that far back in time, we need to look deeper into space. All because it takes light time to travel from there to us. So the farther we look, the further we glimpse back in time. To find the first galaxies, James Webb is going to make an ultra-deep, near-infrared survey of the universe. Then it'll follow it up with a few other methods of research. Now, as you remember, the gas between stars and galaxies in the early universe was opaque, and energetic starlight couldn't penetrate it. But then, about 1 billion years after the Big Bang, it suddenly became completely transparent. Why? The James Webb Telescope might have found the reason. At one point in the past, the first galaxy's stars emitted enough light to ionize and heat the gas around them. This helped clear the view over hundreds of millions of years. The newest insights scientists got were about a time period called the era of reionization. That's when the universe underwent some dramatic changes. After the Big Bang, gas in the universe was unbelievably hot and dense. Hundreds of millions of years passed, and it cooled down. But then, something baffling happened. It was as if the universe hit the repeat button, and the gas became ionized and hot once again. It could have happened because of the formation of early stars. After that, millions of years later, this concoction became transparent. For a long time, researchers have been hoping to find definite evidence that could explain these changes. And now, the telescope has finally shown that those transparent regions are located around galaxies. Astronomers have seen these galaxies ionize the gas surrounding them. Even better, they have managed to measure how large these transparent regions are. They're ginormous compared to the galaxies themselves. Imagine a hot air balloon, and now imagine a pea floating inside. You've got it. And guess what? These tiny galaxies drove the entire reionization process, clearing huge regions of space around them. These transparent bubbles kept growing until they merged and caused the entire universe to become transparent. The research team chose to target a period of time before the end of the era of reionization. At that time, the universe was not quite opaque, but not quite clear either. It was a patchwork of regions of gas in different states. To find out this cool fact, the astronomers aimed the James Webb Telescope in the direction of a quasar, an incredibly bright space object. It acted as a gigantic flashlight, traveling toward us through different regions of gas. It was either absorbed by the patches of near opaque or moved freely through the areas where the gas was transparent. The scientists then used Webb to examine galaxies in that region of space. They found out that these galaxies were usually surrounded by transparent regions with a radius of about 2 million light years. For comparison, The area the galaxies cleared was almost the same distance as the space between our home Milky Way galaxy and our nearest neighbor, the Andromeda Galaxy, and the telescope witnessed those galaxies in the process of clearing the space around them. It was the end of the era of Ryanization. Until then, no one had evidence of what caused Ryanization. The team is planning to dive into research about other galaxies in 5 additional fields. The Webb telescope's results from the first field have been overwhelmingly clear. And even though the astronomers had expected to identify a few dozen galaxies existing during the era of Ryanization, they actually managed to spot 117. Now, let's talk a bit about the main hero of today's show, the James Webb Space Telescope. It is an absolutely stunning piece of equipment, which is around 100 times more powerful than the Hubble Space Telescope, and the latter has observed places that are 13.4 billion light-years away. The James Webb Telescope is also on the pricey side, to put it mildly. Even though originally the cost of the telescope was estimated to be just $1 to $3.5 billion, the whole development process cost around $10 billion. For comparison, it cost NASA $4.7 billion to build and launch the Hubble telescope, and it was another $1.1 billion to fix it in orbit. Even though the James Webb Space Telescope itself is 3 stories high and the size of a tennis court, its mirrors are the lightest large telescope mirrors of all time. During the manufacturing process, they underwent a 92% reduction in weight. When you look at them, the telescope's mirrors seem to be gold, but in reality they're made of beryllium. This is a steel gray, lightweight, and brittle metal. A gold coating is applied to each mirror, that's true, but they can't be produced entirely out of gold since this precious material tends to expand and contract even with small temperature changes. So, the total amount of gold in the James Webb Space Telescope is less than 60 grams. That's a golf-sized piece of gold, and the gold plates covering the mirror are less than 1,000 atoms thick. As for the telescope's abilities, it would be able to clearly see a US penny from 38 kilometers away and a football from 547 kilometers away. James Webb's telescope side is cooling itself down, and its temperature doesn't rise higher than minus 223 degrees Celsius. That's cool enough to make nitrogen liquid. A truly enormous 5-layered sun shield surrounds the telescope and reflects away as much sunlight as possible, letting the telescope stay cool. At a distance of 640 light-years from the Sun, scientists discovered planet WASP-76b, where it rains iron. The planet is very close to its Sun and always turned to it with the same side. The term is tidally locked. The temperature on the sunny side is so high that metals melt and evaporate there. The other half of the planet is cool enough so that metals condense again and fall down as rain. Speaking of tidal locks, our moon is the same way. There's no dark side to our satellite. It's just always turned to us with one side. When the moon happens to be in between the Earth and the Sun, what we call its dark side becomes brightly lit. We just can't see it from our planet. Figures. A recent study claims that the moon has a tail, and every month it wraps around our planet like a scarf. A slender tail made up of millions of atoms of sodium follows Earth's natural satellite, and our planet regularly travels directly through it. Meteor strikes blast these sodium atoms out of the moon's surface and further into space. You won't believe it, but the moon seems to be shrinking. Earth's natural satellite is now 150 FT smaller than it used to be, hundreds of millions of years ago. The reason for this phenomenon might be the cooling of the moon's insides. It could also explain the quakes shaking the surface of our planet's natural satellite. Astronomers have recently found out that Mars is seismically active. Mars quakes occur there on a regular basis. For several days every month, the moon remains between the Sun and our planet. That's when Earth's gravity picks up that sodium tail. Our planet drags it into a long stripe that wraps around its atmosphere. This lunar tail is totally harmless. It's also invisible to the human eye, 50 times dimmer than what you can perceive. But during those rare days, high-powered telescopes can spot its faint yellowish glow in the sky. The tail looks like a gleaming spot that's 5 times the full moon's diameter. Turns out there are plenty of planets in the universe, and even in the Milky Way galaxy, that have liquid or frozen water on them. The closest one is within our solar system. It's Europa, one of Jupiter's moons. Scientists are almost sure that underneath its frozen surface, there's an actual ocean of water. But it's too soon to be hyped about possible life on such planets. Liquid water is only one of many things that have to come together for life to appear on a planet. A star in the galaxy GSN 069 is likely to turn into a planet the size of Jupiter in the next trillion years. It might happen because of the star's regular encounters with a black hole. First, astronomers noticed unusual X-ray bursts that were strangely bright. They went off every 9 hours. After studying this phenomenon for some time, the scientists realized it was a star moving in a unique orbit around a black hole. The dazzling flashes? It was the material getting slurped off the star's surface by the black hole. It turned out that over millions of years, the black hole had already transformed the red giant into a white dwarf. And the process isn't going to stop whatsoever. Astronomers have found some traces of phosphine in the atmosphere of Venus. On our planet, this gas, colorless and flammable, is often found where microbes live. No wonder a new theory suggests there might be life on Venus. But even if there was some life on the evening star, it could have only appeared in its atmosphere. Probably no living organism would be able to survive the planet's extreme environment. Venus's surface is extremely dry. There's no liquid water on the planet, and the pressure there is 90 times greater than that on Earth's surface. Atmospheric pressure, 90 times more. The temperatures often rise higher than 900 F. That's hot enough to melt some metals. As for vacations there, I'll pass. In fact, there's a place millions of light years away where there's a whole floating space cloud made entirely of water. There's so much of it that it could fill all our oceans 140 trillion times over. Slightly more than what we need. Water on Earth is actually a puzzle shrouded in mystery and covered with riddles. The most popular theory is that it was brought to our planet by icy comets and asteroids that left behind not only mighty craters, but the liquid substance thanks to which we can now thrive. But in space, there's a whole lot of organic matter, and under specific conditions, it could yield so much water, it would be enough to fill our oceans 1,000 times over. Researchers conducted an experiment in which they heated this organic matter and obtained clear water and oil. If this is confirmed in future studies, it could mean that even oil appeared on Earth, not only thanks to fossilized remains of living beings, but came from outer space as well. And yet, there just might be about 6 billion Earth-like planets in the Milky Way galaxy alone. The latest data has shown that every fifth Sun-like star can have at least one planet in its habitable zone. And not just any planet, mind you. It has a rocky core and surface, and it's of comparable size to the Earth. Being inside the habitable zone of its star, such a planet would have high chances of becoming home to living creatures. Microbes, at least. And if there are billions of these planets in our galaxy, you could safely say that at least one of them is not only habitable, but inhabited already. And now, multiply this by the number of galaxies in the universe, also considering that many of them are much bigger than the Milky Way. This gives us billions upon billions of Sun-like stars and Earth-like planets, and some of them are surely more like ours than others. And get this, we might be able to walk upright because of supernova explosions. About 2.5 million years ago, a supernova sent cosmic rays to our planet. They triggered a series of electrical storms in the Earth's atmosphere, which turned into thunderstorms. Those, in their turn, caused wildfires in Northeast Africa, where our earlier ancestors lived. Fires turned the forest area into a savanna, the atmospheric pressure changed, and our ancestors had to stand on 2 legs to survive. The biggest explosion since the Big Bang was registered in 2019. This happened in the Ophiuchus cluster, which unites thousands of galaxies. According to scientists, the blast was equal to 20 billion, that's 18 zeros, megaton explosions happening once a millisecond for 240 million years. I'll have to trust that. My math is not that good. In 2019, NASA's InSight lander, whose goal was to study the interior of Mars, registered the first Mars quake ever. These quakes were coming fast, about 2 per day. Most of them were tiny. You wouldn't even feel them if they happened on our planet. So far, more than 300 Mars quakes have been detected. Those are the first quakes on any space body other than Earth and the Moon. Another mysterious phenomenon discovered by the mission was bizarre magnetic pulses. They occurred every midnight around the lander. It's still unclear what those pulses were. Maybe after midnight, they're going to let it all hang out, or something. Pluto's atmosphere rises much higher above the surface of the dwarf planet than, let's say, Earth's. It also has more than 20 layers, all of them freezing cold and extremely condensed. Remember the asteroid that wiped out the dinosaurs on Earth? I wasn't around then, but who could forget? There might have been another space show that ended badly for at least 75% of all life on our planet in the past. Roughly 360 million years ago, a supernova explosion occurred about 65 light-years away from us, and the cosmic rays sent by it swept away the ozone layer of our pretty blue ball. Wow, tough neighborhood.
It's been more than a year since the James Webb Telescope, which had taken over 20 years to complete, was launched. And for such a relatively short time, the ultra-modern and most powerful in history piece of equipment has already made plenty of discoveries. By observing the universe at infrared wavelength, James Webb lets us see things no other telescope has ever shown before. The primary goal of this incredible piece of equipment is to study the formation of galaxies and stars that appeared in the early universe. For example, look at the closest to us stellar nursery, a region of space where new stars get born. NASA has shared an image from James Webb that shows a small star-forming region. If you look at the picture attentively, you'll see jets bursting from infant stars. Around them, different colored clouds of cosmic dust are colliding with one another. The view is mesmerizing. The red dust consists of molecular hydrogen. You can also notice that some stars have something like shadows. Those hint at the creation of what will later become planets. At first sight, the image may seem chaotic, but astronomers claim that it's a relatively small and quiet stellar nursery in comparison to some others. Many young stars there are similar in size to our sun or a bit smaller. The photo itself was taken with the help of Webb's near-infrared camera, NIRCam. It's the observatory's primary camera that snaps images of the cosmos in 2 different infrared ranges. Another amazing discovery the Webb telescope has made is smoke molecules in a distant galaxy. It's the first time such molecules have been discovered so far away from our planet. The galaxy in question lies 12.3 billion light-years away from Earth. It most likely formed about 1.5 billion years after the Big Bang. Despite such a huge distance between the galaxy and our planet, scientists have managed to detect chemical compounds found in soot or smoke. And it's quite a big deal since it has pushed the record for detecting similar, complex molecules back by around 1 billion years. This study has also confirmed the sheer power of the coolest piece of space equipment of all time. It managed to make this discovery despite the fact that the spectrometer needed for the measurements didn't perform to the fullest after having experienced a sudden and surprising degradation. The James Webb Telescope has also helped to boost our understanding of exoplanets. Those are planets orbiting stars other than our own sun. At the beginning of 2023, the observatory spotted its first exoplanet, CHES 475b. It's located 41 light-years away from Earth and is approximately the same size as our planet. According to NASA, nowadays, James Webb is the only operating telescope capable of categorizing the atmosphere of Earth-sized exoplanets. The research team behind the discovery believes such results underline the precision of the telescope. They hope that it will help us locate many more rocky exoplanets that we might be able to colonize in the future. Even though, at first sight, it may seem that the universe is pretty empty, it's actually a very busy place. And Webb has all the necessary instruments to see all kinds of cosmic events happening out there. Just look at this image of WR124. It's a star on the cusp of its explosive demise. In the image, the star is about to go supernova. It happens when a star runs out of its fuel and explodes at the end of its life cycle. releasing a giant cloud of space dust and hot gas into space. The star captured by the Webb telescope was at the Wolf-Rayet stage of its life. That's a period when a star is shedding its outer layers before going supernova. The next amazing thing discovered by James Webb is a star-planet hybrid with very strange clouds. This bizarre world, VS 1256b, is actually a brown dwarf. Those are bigger than planets but too small to classify as stars. They emit some light of their own and are quite hot, but their mass is simply not enough to fuse hydrogen into helium, like full-fledged stars do. Space bodies of this kind aren't actually brown. They occur in a wide variety of colors, but those are mostly invisible to the human eye. What we can see is the light they emit, and to us, it appears to be dark orange or magenta. The brown dwarf discovered by the Webb telescope is almost 20 times the size of Jupiter. It orbits 2 red dwarf stars, and to complete one orbit, it needs over 10,000 years. Astronomers first found out about this unusual exoplanet in 2016, but at that time, they didn't classify it as a brown dwarf, and thus couldn't explain its puzzling reddish glow. Now, thanks to the James Webb Telescope, they know the space object's origin. Anyway, back to those clouds. As you know, clouds on Earth are made of water vapor, but those on the brown dwarf are different. They seem to be made of sand. It looks like good old sand from Earth, but it's actually not. The clouds are made of tiny particles of silicate. Another recent discovery involves several large galaxies that scientists believe were born not long after the Big Bang. They aren't supposed to be there, and no one expected to find them, but the James Webb Space Telescope has spotted them. These galaxies, as massive as our home Milky Way, are full of mature red stars. Astronomers have analyzed the light coming from them and estimated their age. 500 to 700 million years after the Big Bang. It means that they came into being when our universe was very young, almost a baby. But the most bizarre thing about these galaxies is their tremendous size and the age of the stars dwelling there. The data received by the telescope don't coincide with the existing ideas about what the universe looked like and how it evolved in its early years. It also doesn't match the earlier observations made by Hubble. And here, James Webb has captured a distant region of space in unprecedented detail. This section of space is known as Pandora's cluster. In the image, you can see 3 massive clusters of galaxies coming together and forming a megacluster. The combined mass of these clusters acts as a powerful gravitational lens, and thanks to this natural magnification effect, scientists can see other galaxies in the region. Astronomers claim that the most recent image of Pandora's cluster is stronger and deeper than they have ever seen. James Webb has also managed to spot thousands of young stars never seen before in the Tarantula Nebula. This space formation got its nickname because of the appearance of dusty filaments spotted in previous images. It's the biggest star-forming region in the local group, which includes the galaxies nearest to the Milky Way. The Webb telescope's images have helped to shed light on the composition of the Tarantula Nebula. The telescope has also detected protostars, infant stars in the process of gaining mass. Astronomers expect that these protostars will eventually form and shape the nebula further. Among other discoveries made by the James Webb Telescope, you can see the birth of 50 distant stars. Some of them power protoplanetary disks, which might later form solar systems, light years away from our own. Here is one more image from James Webb. You can see a supermassive black hole that has a mass of 9 billion suns. It's so ginormous and ancient that scientists are struggling to explain its existence. Astronomers have also discovered a distant ring of dust, rock, and gas that contains a chemical called methylcation. It's known as a molecular building block of life, and it makes most of the organic material on our planet. James Webb helped researchers see powerful sandstorms on a planet 378 trillion kilometers away. Astronomers were happy to discover this treasure chest of countless tiny sand particles. Now look at this. Do you recognize this image? Those are the so-called pillars of creation, but this new view shows us just how star-speckled that dusty region actually is. You can compare the new photo with the one taken by Hubble in 2014. This is astonishing proof of scientific progress. There's this mysterious thing in space, an unusual spot that scientists haven't been able to explain for more than 15 years. There are different theories, and one of them says that maybe this is an imprint from a collision with a parallel universe. Is this true? Well, let's see. Take a look at this map. This is the map of our universe. Well, not really. This is actually the map of cosmic microwave background radiation, or simply CMB. Many billions of years ago, there was a Big Bang. It was so powerful that it created our entire universe. And, of course, such an event couldn't occur without leaving some consequences. And these consequences are literally everywhere. The Big Bang left electromagnetic radiation, which we know as CMB. We don't notice it in our daily lives, but it's literally here, under our noses. And if you had some kind of superhuman vision, you would see how everything around you shines with this dim light. This radiation is very important. If we hadn't discovered the CMB, we would have never found out about the Big Bang. Previously, scientists believed that the universe had always existed, there was no beginning, and there won't be an end. It sounds pretty ridiculous to us now, but less than a century ago, people were absolutely sure of it. Stephen Hawking was one of the first scientists to guess that the universe did, in fact, have a beginning. The guy was so cool that he realized this as a student while working on his doctoral dissertation. But unfortunately, he had no proof. If there was such a strong bang billions of years ago, then where are the traces? Where's the proof? Laughed people who believed in the eternal static universe theory. But don't worry, they had the proof rubbed in their faces real soon. In 1965, astronomers Arno Penzias and Robert Wilson discovered CMB, and that was the first grandiose proof of the Big Bang. It turned out that radiation was everywhere, we just didn't notice it. In fact, at first, Penzias and Wilson themselves mistook it for the noise of a big city, or pigeons, or something else. For their discovery, which turned the world of science upside down, they received the Nobel Prize. Alright, so people learned that they were surrounded by electromagnetic radiation. Then they started collecting more data about it. They accumulated more and more info over the years until they made this very map. This is a map of CMB temperatures. But while creating it, scientists discovered something unusual. Let's take a look at this map. It looks like a large and diverse pattern of cold and warm places. But in reality, our universe is quite uniform. All temperatures on this map are close to 455 degrees Celsius with very little difference. All temperature fluctuations between these places are small, and each tiny speck actually spreads over millions of light years. So, everything in our world is pretty calm and stable. Except for one point, this cold spot right here. Astronomers first discovered it in 2004. First, it looked like nothing unusual. It's just a region where the temperature is below average for a couple of microkelvins. But remember, we're not talking about a small area. This is a giant cold region. It's literally billions of light years in size. Wait, the scientists thought, this can't be true. The universe should be consistent everywhere. According to our standard model, this cold spot simply shouldn't exist. But it does exist though. This isn't just some mathematical error. It's right there. So what is this cold spot? And how did it appear? Astronomers have been trying to find the answers to these questions for years. Even now, we have only a few theories. So let's discuss them all. Theory 1. Cosmic texture. This idea was brought up at the end of 2007. Then scientists suggested that this cold spot could be the hills of space. In other words, it may be a bumpy region of the universe, just part of its texture. But that's a silly explanation, so this theory was quickly discarded. Theory 2. The supervoid. This hypothesis was considered the most plausible for a while. It stated that the cold spot was actually the so-called supervoid. It's a terrifying, dark place of our universe with almost no galaxies. And because it's an empty region with almost no stuff in there, it seems cold to us. However, this theory was refuted in May 2017. After carefully examining the cold spot, scientists found out that there were no signs of a supervoid there. Moreover, voids and supervoids, which actually exist by the way, are still very small in size. The cold spot is literally thousands of times bigger than them, so there must be some other explanation, and there is one, perhaps the most bizarre of them all. Theory 3. A parallel universe. This controversial idea was put forward by cosmologist and theoretical physicist Laura Mersini Houghton. She suggested that the cold spot could be an imprint from the collision of our universe with a parallel one. Standard cosmology cannot explain such a giant cosmic hole, says Mersini Houghton. This is the unmistakable imprint of another universe beyond the edge of our own. Her assumption is based on the theory of the multiverse. This theory says that there's actually an infinite number of universes like ours in the world. They constantly collide with each other, giving each other a push, which creates a new Big Bang. So maybe the cold spot is a bruise from such a collision? For quantum mechanics, such crazy theories are pretty common. But for standard physics and our simple understanding of the world, this is earth-shattering. Of course, we need strong evidence. And Mersini Houghton's team has begun to work on it. Professor Tom Shanks from the Center for Extragalactic Astronomy at Durham University also participates in this research. The craziest sounding of the exotic models for the explanation of the cold spot, the multiverse is actually the most standard in terms of our current model of the universe, he wrote in one of his works. So, what evidence do we need? Well, our cold spot is located in the southern hemisphere. According to Shanks, if there really was a collision between two universes, we should find another cold spot, and it should be in the opposite, northern hemisphere. If astronomers actually found it, this theory would be confirmed, and it'd become the first proof of the existence of a parallel universe. But it's not that easy. To find a second spot, we need the latest highly sensitive telescopes. We also need to find out some info about the nature of dark energy, how it affects space, and, in other words, there's still a lot of work to do. Not so long ago, scientists actually believed they had discovered the second spot. Researchers from New Mexico thought they had found it in the northern hemisphere, but unfortunately, this is likely to be a mistake. The map these researchers used had a high measure of randomness, so it's possible that their discovery is just an accident caused by other voids. So basically, we haven't found another cold spot so far despite careful analyses. But again, even the best modern equipment is not perfect, and it doesn't mean that there's no second spot, it just means that we haven't found it yet. But if one day we did find it, it could change the world of science forever. We'd confirm not only the theory of parallel universes, but also the famous string theory, and it could explain everything that occurs in our world. But if this happens, we'll get even more questions than we already have. How did these two universes collide? How does it all work? So far, it's all just guesswork. We can't claim that the cold spot is a print from the collision of parallel universes. But we can't refute this either. Actually, we may never know the truth at all, but it's still interesting to strive for it.